Good day, doctor. My name is Thineswaran. My ticket number EA235 together with my crew members Vasantha, Rajaram, EA240, PAVITHRAN, T.RAMAS, EA234. So today I would like to discuss about single phase open circuit in Simulink. Before we run the simulation, let's see the parameters. 240 for the peak value, and then the hertz we set for 50, and then the transformer, the unit SI, nominal power 250 volt, and then 120 volt for the primary, together with secondary is a 416 volt. So let's start the simulation. So after run the simulation, here's the value for the power factor, nearly 2 volt. Then current together with VOC, open circuit. So here the parameter for the IC, power factor of open circuit, and then RC, IM. So inside this subsystem, it's contain a mathematical block to obtain this value. So now we discuss about single phase short circuit. Only the difference at the transformer, we short positive polarity and the negative polarity we short, so that we using the same parameter, even follow it by the transformer itself. So let's start the simulation. So yeah, here the result for the short circuit power, current, and then voltage 240 voltage. At this side is represented as a ZSC, XC, and then R equivalent for the short circuit. Inside the subsystem, same as mathematical blocks included. So now three-phase open circuit. So consider here the transformer about the three-phase. So the connection like so star delta. Here the parameters. SI unit again the same, and then nominal power 2000, and then primary winding 400 volt, and then secondary winding 4160, and then the voltage for the first 240 square root of 2, and then times with square root of 2, because the 3 is a three phase, so that we have to do calculation square root 3, and then the phase degree is -20, the frequency 150, and then second also the same, and then here the differences, phase degree is 0, and then frequency is same 50, and then again phase degree 120. So here we use mux for connect 3 input, also the same, so VABC and IABC. So here the tag, and then also here. So let's start the simulation. So we get the power 0.00439 volt, and then voltage 1386, the current 5427 milliampere. So here, okay. So first power factor, we get this number, and then the sign is 1, and the IC value 3.16 milliampere, sorry, micro, and then RC, XM, and lastly IM. So now let's see three-phase short circuit. Also the same procedure to done this circuit. The only difference at here, we short the secondary part, A to C, and then B straight to connect, and then we also provide a ground, same as the previous circuit for open test three-phase. So let us start the simulation. So after run the simulation, we get a power value and the voltage 1386, and then the current is for 5.90 ampere. So here the R equivalent, and then X reactance, and then impedance. So that's all from us. Thank you so much.